All right. So, hello everyone. My name is Viraj, and today we are going to have post-contest discussion for Codeforces round 952, Division 4, if I'm not wrong. Yeah, 952, Division 4. So, we'll be discussing problems from A to H1. That's a total of 8 problems. We'll be talking about the ideas, the observation of how I actually solve them, and what insights can we have while solving such problems. All right. So diff 4 is like the beginner contest. So obviously the problems, at least the first few problems are kind of very easy. But then if you're a beginner, this becomes a very crucial video for you to actually realize what implementation can I do on some problem, what sort of a maybe some math trick I can use, and what complexity should I actually expect and think if I start off with a problem. All right. So I hope I'm audible. Let us start. All right. Problem A, creating words. All right. So now it's a very, very, very easy problem, even to read and even to understand. Expected, it's a diff 4 problem. That's also the first problem of diff 4. So we'll quickly go through the problem. Matthew is given two strings A and B. Both are of length 3. Now he thinks it's particularly funny to create two new words by swapping the first character of A with the first character of B. He wants you to output A and B after the swap. So very, very simple problem. He wants you to swap the first letter of A and the first letter of B, and then you output A and B. Now this can be done by any method. You can take a different character, do that. Any of sort the case, it is not at all necessary that the implementation should match my implementation, or you should have a very specific implementation. There can be various methods to do this. Yes. Now they've given you a very small thing. Note that new words may not necessarily be different. That's all right. They are just giving you a heads up that just swap and print, not an issue not an issue otherwise, right? Now test cases are small and you can see A and B are given. So we'll see the strings, let's say bit and set. Replace this B, replace this S, it becomes sit and bet now. And then you can print it. Similarly, cat and dog become dat and cock, so on, so on, so on. And very simple test case, very simple question. So I can actually directly, I think, move on to the code part, right? Because it doesn't have a lot of discussion to do. Actually, you can start off by taking the input of the test cases. Then you can actually go on to take the while loop of the test case, take the input of string A and B. So this is actually simply saying taking input. And after you have taken input, you can swap the first letter of A and B. Correct. Now, swapping the first letter of A and B, it's going to be very simple that I can actually use a STL function that's swap that's already present in C++, right? So you can use swap function. You can pass the first letter A, pass the first letter of B, that's B of 0, B of A, indirectly in a string, because you know that every index has a character, so it can be called like this notation, and swap it up. And then you can print it. All right. Now, obviously, this can be done in any method. You can take a maybe third character, swap with that, maybe a temporary variable, something like that. It's all totally up to you. All right. So now what is going to be the time complexity for this? Obviously, I will have a time complexity of, I should say, constant. Yes, if I'm not wrong, I think the STL function that I'm using over here has a constant time complexity to swap, and I'm only taking the input of the strings, correct? And then for space complexity also, I can, like, if I'm not taking into consideration whatever space I used up to store the string, although even if I take that both ways, I can say it is fully constant. So a very simple question, constant time, constant space, direct approach. All right, any doubts? Can we move on? Very simple problem, yes? All right, so I think I can move on. All right, problem B. Let us read the problem. Maximum multiple sum. So given an integer n, you have to find an integer x such that 2 less than x, 2 is less than equal to x, is less than equal to n. That means simply x belongs in 2 to n range. And then the sum of multiples of x that are less than or equal to n is maximized. More formally, x plus 2x plus 3x plus so on till kx, where kx is less than n, is maximized. This is simply given to you. Now you have to print x. All right, don't look at the question and simply think that you have to print the sum. All right, so that was something I also misread in the first go. So if you have been given the test cases, that's 100. N is given in 100 order also, so n is also very small. Even if you come up with a n square n cube solution, that's also going to work, not going to be a problem. But what is the intuition behind the idea? Like, you can very well come up with a very simple and a mathematical proved approach over here, right? Let us try to look at the case. So if 3 is given, then the answer is 3. Why? They are saying that if n was 3, then all the possible values are simply x2 and x3, because if n is 3, then you have from 2 to 3 range. Now, if you take the multiples of 2 less than equal to 3, then it will only come as 2. That's giving you a sum of 2. But if you take 3, then the sum is 3. And then 3 becomes the optimal value because 3 as a sum is greater than 2. So you will print the answer as 3. But now for the output of 15, you can very well see that if n is 15, then the optimal value of x is 2. Now they have said why? Because if you take x as 2, then you will have all the multiples of 2 less than 15 getting added. So that means 2, 4, 6, 8, 10, 12, 15, 14, so on, so on. Till like 14 is the largest. I cannot go above that because next multiple would be 16 and 16 is greater than 15. This gives me a sum of 56, which can be proven that it's the maximal of all possible values. Now, when I read the problem, or if you're a beginner, if you read this problem, very well go through the test cases, right? Because sometimes in the very initial problems, especially for diff4 and diff3, the problem hint is given in the explanation only. Given over here, look at this part, which can be proven that is the maximal over all possible values of x. Now, this gives me a hint. When they took x equals to 2, they are saying this is the maximum. Now, if I think logically, I should take x to be a value which is not very large. Does this make sense? Because if I want to add everything up that are the multiples of x less than equal to n, and I want that final value to be very high. Let's try to actually write this mathematically. So you're saying that you start off with x, then you have plus 2x plus 3x, so on, so on, so on. And you want to do this summing of everything till you find something like a kx, where you finally say that kx is actually less than n. Correct? Now, it is very obvious that if I increase x, if I increase this term, then naturally the values, these values, like currently I know that the sum of these values is like x plus 2x plus 3x plus 4x, so on, so on, so on, so on. I would be like, let's say this number of terms were, let's say a terms, a number of terms were here. Then I know if I increase x, let's say this was for x1, and then let's say I created some x2, knowing that x2 is greater than x1. Then that means the sum I would receive is x2 plus 2x2 plus 3x2 plus so on till kx2. Now it's very obvious, right? Because you increased x2, this term is going to reach n faster. Because it is going to reach n faster, that means the number of terms over here, if let's say the number of terms are b over here, then b is definitely going to be less than a. Does this make sense? I'm not trying to overcomplicate the problem because I'm just trying to build the intuition in this part, right? If I have number of terms b over here, then it's going to be less than a. That's very clear. Indirectly telling me that x should not be very large. If I take x to be very large, I'll be reaching very fast, and then the sum I'll be creating would not be very, very beneficial for me. And then in a more formal proof, what you can actually think about this is, in the second case, they took x as 2. Now, imagine this, like even for, like, let's say I'll take up some more numbers. Let's say n was given 9 to you, all right? Now for 9, one thing is like you can take from 2, 3, 4, 5, 6, 7, 8, 9, anything like this. Yes. Now my argument is ideal case is to take 2. Why? Can anybody tell me? By intuition, general intuition, why do you think 2 is the best case? I mean, because 2 is the smallest over here, then first of all, I know that 2 is going to give me the power to have maximum number of terms. It will take more values to use the target. Exactly, Yash. That's correct. As we saw previously, if I take 2, 2 is going to give me the best and the most power to have as many as terms possible before I reach a value that goes greater than n. Make sense? So if I take 2, see, I have 2, 4, 6, 8. I have 4 terms. Let's talk about 3. I have only 3, 6, and 9. Then about 4, I have 4 and 8. Then about 5, I have 5, only 5. Then 6, only 6, 7, only 8, 8, only 8, 9, only 9. Now take this sum. Very clearly, you can see that this sum is very high. This sum is actually the highest of all the sums. So by a very induction or an intuitive based proving, can we not come up with a direct approach and say that it makes sense for me to take x equal to 2 always? Yes, because x equal to 2 is going to give me the largest sum possible, due to the reason that x being so low, that is the lowest possible, that's 2, is going to give me the power to have many terms that are getting added as compared to bigger numbers of x, as we saw over here. Make sense? Is everyone catching up till here? Yes? All right, cool. Now, when you actually take this into consideration, you will argue that, all right, for x equal to 3, this doesn't follow. For x equal to 3, the answer is 3. Then this becomes an edge case if you think otherwise. If I was talking about the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on, so on, so on. For all like 10 to 12 numbers, you can actually do this on pen and pencil with your paper, with a pen and pencil and paper, and you will realize that even for this number n, answer x is 2 case best possible. For 4 also, this is best. For this also best, and so on, so on, so on. 2 is the best everywhere. Only this number is being a problem. And why is this being a problem? It kind of makes the problem like a fun problem otherwise for the edge case, which we saw in the problem explanation itself. If you take n as 3, then in this case, only 2 doesn't work, because there is obviously a sum you can directly take, that is 3, and 3 is definitely greater than 2. So by intuition, this becomes simple that I should print, if n is 3, I should print a 3. And if n is any other number besides 3, I can simply print 2. Is this intuition clear with everyone? Like you can take a pen and paper and actually write down this part and you will get this very clearly. All right. Cool. So let me jump to the code. All right. Very simple code. Take the input of n. If n is 3, print 3, else print 2. All right. Now this is a simplest approach I can have. Nothing more shorter than this can be created as to my need. All right. Now, what is the time complexity? Obviously constant. Yes. And what is the space complexity? Obviously constant. Because I am only taking the input of n and I'm not using anything like other than a simple if and else check to print my answers. Is this clear with everyone? Clear. All right. Cool. All right, good to see you guys are falling till here. Let me actually rub off this. Yeah. All right, let's move. Problem C. Will there not be any other edge case possible? No, exactly. Like there won't be any other edge case possible, because like larger the values of n you go, higher it would be better that you take x equal to 2 intuitively. Because if you take x equal to 2, you will be getting a higher command of more number of terms. Like I think there would be some mathematical proof to this part also, right? To actually get this out in the way. But then this edge case is something that is like what happens in differ problems. It's a mental note for you guys that differ problems have the like 99% of the problems have the edge cases only in the sample case. So like they actually, because the problems are made so easy for beginners that they don't try to bring up such a case where they will give you an edge case that was not there in the sample. This is by observation. This is by experience, I'm telling you, right? So again, I'm not saying this is always true or this is something you should always follow, something like that, blindly. But many of the times my experience has observed this, that in initial problems, edge cases are present in the sample case only. There's nothing beyond that part. So that is one point. That is one point when I was doing this problem came to my mind, that if it's mentioned over here, this is the only case. And the other thing is obviously intuitive, that I explained. More number of terms in higher number of n. So that gives me a bigger command on creating a larger sum. And because that gives me a bigger command on creating a larger sum, that gives me a better power. So x equal to 2 makes sense. All right, Sean. All right, so I think it's clear for everyone. Let's move on. Good prefixes. Problem C. Alex thinks some array is good if there exists some element that can be represented as the sum of other elements. Now, the sum of all other elements is 0 if there is no other element. That's all right. For example, the array 1632. I brute forced all possible sum. All right, I mean, that's also great, right? For n equals to 100, that also works. I mean, that's not an issue at all, right? You can brute force this, not a problem. For example, the array 1632 is a good since 1 plus 3 plus 2 is equals to 6. Furthermore, the array 0 is also good. However, the arrays 1, 2, 3, 4 and array 1 are not good. Because like now, if you read this problem, you will understand the goodness meaning, right? If any one number can be represented by sum of all the other elements beside that number, then that array is good array. Make sense? Now, if I'm saying that the array 1, 2, 3, 4 is not good, like this array in itself is not good, that means if I take any one number, all the other numbers sum is not going to give me this number. Yes? Very clear on this part? All right. Now I'll say Alex has this array A1, A2, so on till AN. And you have to help him count the number of good non-empty prefixes of the array A. In the other words, count the number of integers I such that the length I prefix, that is from A1, A2, A3, A4, so on till AI is good. All right. So I'll try to formally prove what the problem means. Given you have the array A1, A2, A3, A4, so on till AN. Then what they're asking you, first of all, they're asking you a count. That's very obvious. They're asking you a count. And what is that count? That count is go to all prefix arrays. All right. So go to all prefix arrays and try to do the following. Say that, all right, this was my first prefix array. This was my second prefix array. This was my third prefix array. This was my fourth prefix array, and so on, so on, so on. So let's say I am talking about this prefix array. In this prefix array, if this prefix array is good, as in if any one number in this prefix array can be represented as the sum of other numbers beside that number, then this array is good. And if this is good, increment my count by 1. And then do this check of goodness for each prefix array and report the final count. Is this problem clear now? Make sense? All right. Now we'll try to actually move on to some general observations. First of all, I'll ask you a very small thing over here. Tell me, when do you think for short an array is good or not? Any ideas on this part? A5, A6, set in AN. At index 0, when only one element. Yeah, okay. I mean, that makes sense, obviously. For only one element, the array is good. That's given in the problem only, right? Sum of all elements 0 if there's no other elements. That's already written. If array of 0 equals to 0, okay. Array of 0 is also good. Like it's naturally good only, right? Because I mean, what more? Like I'm trying to ask something else. All right. I'll try to give some hint. All right. So let's say in this is the array, and let's say you pick up A5. And my argument is A5 is actually the sum of all the elements except A5. Sum of prefix array should be even. Okay. Okay, where is this tending towards? Check in prefix array if max sum is until the prefix, and check if the number says that element is equal to sum by 2, because expression is AK minus AK. Correct. Makes sense. Yes, that makes sense. So I'll try to give you like this part, what you did, no? Sum minus AK equal to AK. I'll try to, yeah, exactly. Somebody said this idea. Gar said this. Small number will contribute to big, so we can check on that. Kind of that idea, right? I'll try to tell you this part. Tell me if I'm talking about A5 and I'm for sure saying that A5 is actually the sum of A1, A2, A3, A4, A6, AN, so on till AN. Then can you very well argue that A5 will be the largest value in the array? Yes or no? Tell me. Yes or no? Do you agree to this idea? Yes. If A5 is the sum of all the elements beside A5 in the array, then it is for short A5 has to be the largest value. If A5 is the second largest or the middle value or something like that, it is never possible. Agreed? Yes. So if A5 is the largest value, only then it is possible. It has a possibility that A5 can be equal to the sum of all the other elements in the array. If A5 is not the largest, then anyways it's not possible. Agreed? Agreed on this idea? Yes? All right. Makes sense. Should I prove this? Or do you guys get this idea? Like, this is a very basic statement I've given. If A5 has to be or has the possibility of being the sum of all the other elements except A5, then A5 has to be the largest value in the array. Or very simply, if any number AI has to be the sum of all elements except AI, then AI has to be the largest element, largest value. Agreed? All right. Exactly sure here. Makes sense, correct? So what we can do is, let's say you have an array A1, A2, A3, A4, A5, A5, A6, AN till AN. Now, if I ask you that what is like, if you can tell me in a very constant time that the array from A1 to A5, is this good or not? Then what should be the condition in this? Whatever is the maximum element in this array, let me call this MX. And whatever is the sum of this array, let me call this S. Then can I say S minus MX should be equal to MX? If this is true, then this array is a good prefix. Make sense? Yes. Max into 2 is equal. Correct. That's the case. Like if you write S minus MX equal to MX, that's actually S equal to 2 into MX. That's also simple. I'm trying to write this like this, that you excluded from X MX and then you checked whether it was equal to MX or not. That's why I wrote it like this. All right. Cool. So does everyone get this idea? Now, if I want to implement this idea, what is going to be my approach? Very simple implementation approach. I can run a for loop. Yes. I can have a sum variable that starts with 0 and an MX variable. That's kind of saying the prefix MX. And you can call this as prefix sum. So what is the sum up till now? And what is this prefix maximum up till now? All right, so I'll explain this again. All right, Bhavya, see this. First of all, we discussed that a good array will be that array in which if I say that any AI is actually giving me the sum of all the other elements, then AI has to be the MX or the maximum element in that array. Do you get this idea, Bhavya? Yes? All right. Now, if I'm talking about this array A1, A2, A3, A4, A5, let's say in this prefix array up till here, up till this part, this prefix array, if I say that this prefix array is good, what does this mean? That whatever is the maximum in this array, let me call this MX as maximum as MX. And whatever is the current sum of this array, let me call that S. Then will I not say that S is the total sum? So if from the total sum, if I remove MX, that will give me the sum of all the elements in the array beside MX. Yes. And now if this value is equal to MX, then that means this is a good array or not. Do you get this, Bhavya? Right. All right. Cool. So it's clear with everyone? All right. So that means what I can do, as I was talking about implementation, I can run a for loop from I equals to 0 to the last element. I have an S equals to 0, that's the sum, and then MX can start with -1 because I want to maximize it. And then inside this for loop, I can write a very, very simple approach. First, let me add on S plus equal to AI, right? Add on, find the max, maximize this max MX comma AI. This gives me the current maximum. And then simple a check if S minus MX is equal to MX C plus plus. That's the counter, or answer whatever you want. Correct? Do you all get the idea? I think the code might not look very clean because of my writing, but we can look at the code part and understand this. All right. So should we jump into the code? All right. Cool. All right. So very simple code. I'm going to take the array, take the n, take the array input. Done and dusted. Now I have two variables, mx, that's -1, s, that's the sum, and then the counter c. Now this mx, actually, I can call this much better, prefix max. And I can call this s as prefix sum. All right. Now what do I do? And this c can become my answer. So I'll say run a loop from 0 to n. First, maximize. So you have prefix max as the current maximum. Then add on to the sum. and then check, is prefix sum minus prefix max equal to prefix max? If yes, increment your answer. And then you can print answer at the end. Any problem in this approach? But what if A2, A3, A4 form a good array? It will not be counted by your approach. Right, Rajat? All right. So that's a good point, actually. I think you missed some part of the question. Look at this question, you will realize that we were asked only the good prefixes of the array. All right, Rajat. So the array you just mentioned, A2, A3, A4, is that a prefix? It's not a prefix, right? Prefix means anything that starts with A1. What keys did you use to reflect changes in the variables at all places? All right, so I am on a Mac. So I am using Command and D. If you are on a Windows, you will be using Control and D. So let's say you are on this, you can highlight this first with a double click. Then I am doing a Command D. You can do a Control D, Control D, Control D. It's going to select everything till you want, like till the case you want. All right. That's all right, Rajat. That don't ever think of that part. It's all right to ask questions. It's all right to get this problem. Everyone is learning over here. All right. Not an issue at all. Cool. Thanks. All right, sure. Welcome. Let's move on. Problem is clear. Let's move on to problem D. All right. Manhattan circle. Now, this was an interesting problem, right? Like, I mean, very, I should say, imaginative problem or something. So I got confused in a very start part, but then, yeah. So, all right. Given an n by m grid consisting only of dot or hash characters, there exists a whole Manhattan circle on the grid. Now, the top left corner of the grid is 1, 1, and the bottom right is n and m. So this is like very standard stuff they have given you. As beginners, you should understand this, that this is how generally grids are represented. And if you're an amateur in this, you know this is how a normal grid representation. Now, what do you mean by Manhattan circle on the grid? Like, obviously, it means circle is there. Then Manhattan is actually defined by a formula. That is what they have mentioned over here. They are saying that a point AB is going to belong to the Manhattan circle centered at h comma a k if h minus a mod plus k minus b mod is less than r, and r is a positive constant. So r is given, actually r means like the radius of the circle. Now, this formula can look very complex. Like I actually looked at the cases and just made my question, because that's what something I want you to understand also, that these are very visual based problems. Like according to me, this was a very visual based problem. All right. So we look at the cases and I'll try to tell you what my idea was. All right. All right. So test cases are small. That's very simple. And then n cross m is 2 into 10 power 5. So for all the beginners out there, don't mistake that n and m both are in 10 power 5 order. N cross n is in 10 power 5 order. That means if you iterate a loop on the 2D array, as in you use 2 loops to iterate on the 2D array, then you will be within your boundaries, because iterating would take an n into m complexity, and n into m together is less than 2 into 10 power 5. All right. So this is something I need to clear for the beginners. And all right, now moving on. So you will be given this grid, nm characters, dot or hash. So let's say I've given over here. Now let's look at the test cases. So they have drawn a very neat circle over here. Let's say this was this grid, 5 cross 6. Center lies in the longest hash part in the row. All right, that's a great idea, actually, Garv. All right, so this is something I have not done. Like I have done some other part. All right, so Shore is also giving an idea. Correct, Shore. It's kind of the same idea I've done for you. All right. All right. Just half the half position from the total. Correct, exactly. I mean, that's actually a great idea. Yeah, I am just realizing this part. This can also be done. Again, I mean, implementation is not a big part for this. All right, so yeah. All right, so I have the array. I have the matrix, and then they have drawn very neat, you can say, circle in this part. Now, one thing is very simple. Yeah, it was too easy for D. Exactly, Rajat. It was too easy for D. Now, very simple thing that is observable over here is, first of all, tell me, do you think you can, like, you have a circle over here which has a diameter 5. You have a circle over here which has a diameter 3. And then you can have a 1 dot circle that's a diameter 1. Meaning the diameter is odd. Now tell me, can you think that the diameter can be even? Like the diameter is not possible to be even, right? Does that make sense? Can we think that the diameter is even? I mean, this is something I thought about directly in the question, but like it makes sense that, although I mean, it doesn't matter either way that if the diameter is not even or odd, because they've not mentioned this. Is just a thought process of mine that I thought maybe that's the case. If not, you can obviously confirm this part. But no, because center will be exactly that's what my thought was, right, Gar? Because then the center will be absurd, because you will not have an exact center. If the whole diameter is even, then you will have by symmetry even sort of two diameters clubbed together. Then the middle area, it won't work out, right? You won't have a single point that can be represented as a center of the circle, correct? So by this visual observation, like, again, this is not something very important. I just wanted to share some idea. Because of this thought process, which I thought simply like, all right, there's no case of even. I mean, it doesn't make sense that it would be even. Other part that came to me was, after I read this, you have a circle and then you only have one circle. So they're not saying in the question that circle might not be there or circle might be. They are saying there is a circle. It's very well drawn for you. Just identify the center. So because they're saying this part, it very clearly makes sense that first I can try, like what my thought approach was. Point number one, I can first try to find the boundaries of the circle. Boundaries of the circle. As in, my first thought process was, what if the circle, like let's say the 5 base circle is somewhat given like this, right? 3, then there is 3, then you have 5 over here, then this is 3 again, and then you have 1. So my thought process was actually to find this boundary. But then when I was actually thinking in this part, one more thing struck to me. If let's say I want the center, this is this, right? This is the center. This center is actually, because I know it's a simply odd base sort of a circle, odd diameter circle. If I find this point and this point, then the middle is going to be the y coordinate. Does this make sense? If I'm able to get the row number of this, let's say I call this row 1, and then if I get the row number of this is row 2, then the middle row, whatever is this mid row, this is going to give me the, not y exactly, I mean whatever coordinate you can actually call this, like the row of this coordinate. Yes. And by similar symmetry case, I can say that if I'm able to find this is like the column 1, where you have hash, and then this column, which has column 2, where you have another hash, then the middle of these two, column 1 and column 2, the middle, just this dotted middle, is going to give you the column for the center. Yes, makes sense? Does this make sense? So what can my simple approach be? I can be like, let me run an iteration, and from the top, find the first row where you find an hash. That is going to be my row 1. From the bottom of the grid, iterate and find the first point where you actually get a hash again. That's the row 2. Then do this similar from the left, the first point where you find a hash, that's column 1. And from the right, find the first point that's a hash, that's column 2. And then you can simply say that row 1 plus row 2 minus row 1 upon 2 is actually the row, and same sort of a formula for column. Any problem in this? Can you understand why I've done this? You want this row. Can you think what this value of row is going to be? It's obviously row 1 plus something. And what is that something? It's the difference by 2. Yes. So the difference, that's row 2 minus row 1 upon 2. That's this extra part that gets added. Or I'll change the pen actually. This becomes row 1, and then this extra part gets added, and that gives the row. And then similar for column, you can write as this like column 1 plus, you can write this as column 2 minus column 1 by 2. Is this clear with everyone? Any doubts why this is happening? Why is this true? Something like that. Clear. All right. So I can jump to the code part. Yes. I mean, again, all right. So on any other approach that was actually like told for this, like the approach, all right. So there's one more approach that was, you can find the longest hash part in the row, and center is going to lie along that. That's also correct approach. All right. You can implement that out. That's also going to work. It's actually a bit more simpler approach than what I said. So kudos to that part. Right. But again, implementation is not a problem. Easier problems tend to have multiple implementations. All right. So I think that is the clear. That's not going to be a blocker for you. All right, cool. Let us look into the code. All right. Take in the n and m input, take in the array A, vector of char, take in the input of that. Done and dusted. Now I have declared some variables. First row, first column, last row, last column. Very simple, intuitive variables like row 1, row 2. This is actually the first row and the last row. Column 1, column 2, first column and last column. Now run a loop. First, I'll run a loop from the top. So first row, find if it's actually equal. If first row is not is equal to -1, make it equal to I and break. And if it's still not equal to -1, break again. So come out of this for loop, double for loop actually, if you think first row has been found. Now do this from a previous end, from the rear end, and do this for the last row. Now run a loop in J queries, J0 to M, and then I inside this to actually iterate column wise first, and then find the first column by similar approach, and then find the last column by the similar approach. Now this is going to come in a zero-based indexing because you're talking about I and J. All right, by not iterating again, performing operations during input time only. All right, that's great. That's great. That's all right. That's not an issue. All right. Because like, I mean, that's when you take actually grades and something like that, it's all right to do that part. All right, cool. Now, because they were in I-based indexing, I did 1-1 addition to all of them because, sorry, zero-based indexing, I did 1-1 addition to all of them because by maths, I want that part. And then this is going to be my answer. First row plus last row minus first row by 2, first column plus last column minus first column by 2. Yeah, I mean, time is going to be still O of n. He's talking about space, right? I think he did not save the array. We can find answer just by finding row 1 and row 2 because column 1 will be equal to column and exactly like that's the case, right? Sure. I mean, you can optimize this very further because there is a symmetry. So it's very like by symmetry, it makes sense that the length of the last row minus first, that's also going to give you the same case, right? So by symmetrical, I know that that's true. I just like I had a very visualized whole version of while I was solving the problem. So I took very good, very so many variables and tried to bring that part. But then again, not a big deal if you implement this anyways. All right. We are going to discuss till H1 Vishwash. All right. Cool. So anyone who has come up with a better approach in this, maybe a shorter code, maybe something like that, it's all right. And kudos to that part. That's so great you were able to do that part. All right. During contest, whatever hits you, whatever rows the boat. That's all the part. All right, cool. All right, so according to my code, currently my time complexity, for me, time complexity is going to be O of n into m, res n into m because I'm iterating to for loops. Very simple. And then space is going to be this extra space if I'm considering, that's saving the 2D array. That's O of n. Is the input time counted? Yeah, correct. Vibho, it's counted. Vibho, sorry, it's counted. Input time. All right. Cool. All right, so we are done and dusted with the D problem. Let me erase this. Let us move on to the problem number E. All right, so now who all you were able to solve problem number E? Like any ideas what you thought? I can have a discussion on 1 minute on this. Me. All right, so Gav solved it. Like this problem was all about figuring out what time complexity will it work in. Yes. Me. All right. All right. So that's a good number actually. Combination of geometry and exactly combination of that part. So I think it would be very tough for me to draw the geometry, right? Because like it's a 3D geometry. I'll try my best actually. But let's try to look at the idea. All right. So now this guy in, I should say Tart is something if n is silent. All right. So all right, XYZ guy has box B with the sides. All right, so not XYZ. Let's say, all right, we can take somebody from the chat only. All right. So Garv has a box B with sides length X, Y, and Z. And it lies in the 3D coordinate plane extending from 0, yeah, careful, correct. I'm careful. We're extending from 0, 0, to X, Y, Z. All right. Now we have a secret box S and Garv wants to choose its dimensions. It's going to be positive sides and the volume is fixed. So the volume has to be equal to K. Now he can place S anywhere in the box B such that S is parallel to all the axes. That means you're not exactly placing it by some rotation or something like that. We'll try to actually showcase what is the meaning of that. And every corner of S lies on an integer coordinate. So this is very simple, right? You cannot place the box S inside S so that you lie in such a geometrical part where you're not on the integer number line anymore. You want to be on the real, you want to be the, sorry, you only want to be on the integer number line. You don't want to be in the real number line. As in, the coordinates cannot start from like 1.1 or something like that. You want integer coordinates. That's very simple to understand. Yes. And then it should be parallel to axis. Now, this is a very simple point. Like parallel to axis, what does this mean? Like, let's talk about this part. Like, imagine, like, if you can see my mouse, imagine if I've taken this box and I rotated it by like 30 degrees or something, and then I kept it inside. This is going to violate. Because if I rotate this by 30 degrees, I know this box is no longer aligned parallelly to all the axes of the outer box. The outer box is the B box. That's the 333 part. And then this inner red box has to align itself. So it needs to be parallel to the axis. Is this clear? The visualization is very important in this part. All right. Yes, it's clear with everyone. Now, S is magical. So when placed at an integer location B, it will not fall to the ground. All right. That's a very stupid point they've given. And it's inside a box. It won't fall. Simple. Among all possible ways to choose the dimensions of S, determine the maximum number of distinct locations he can choose to place his secret box S inside the B. Now, I don't rotate S once its side lengths are selected. That means if I have selected how the placement of a box would be, then I only move it, don't rotate it. Can you, like, or to be very specific, in mathematical language, we actually call this only translation and no transformation or no rotation. I'll write this part for you. Only translation. Only translation. Is this part clear with you? Is there anyone who is not able to visualize this part when I say only translation, or when it's written over here that you cannot rotate once side lengths are selected? If you have any doubt, I'll try to draw a diagram for this part anyways. Let's see if I can actually quickly draw up something. Okay. This can be an outer cube. All right. Yep. This is a cube. And then let's say the inside box, it's somewhere like this. Yeah, something like this. All right. All right, draw diagram, please. Exactly, yes, that's what I mean. So up, down, left, right, from the back. Exactly, Sean. That's what I mean. Now look at this red. All right, look at this red. All right. This red, you understand this, like if this point is origin, right? This green point, I'll try to show this. This green point is the origin. Yes. This is your x-axis, this is your y-axis, and this is your z-axis. Any problem? Now this outside blue box is the box B, and this inside box is S. Now I have placed this over here. Now, what do I mean by not rotation? That means if I've selected that, I'm going to place the box like this, as in this order. What means is I can only slide it in X direction, or slide it in the Y direction, or slide it in the Z direction. Only slide. I can do that in all three directions, maybe two directions, maybe one direction. I cannot rotate it like this. Is it clear? Yash, Sean, or any other person who was actually confused about this? Do you get this part? All right, cool. All right. So I think this part is clear. Now comes the idea. Now over here, first of all, very simple thing. There can be multiple possibilities of S, as in dimensions of S. Correct? You know that only the volume of S is fixed, that is K, that is given to you in the problem. Now T is given 2000, X, Y, Z is given, and X, Y, Z, K, all are actually like X, Y, Z is in 2000 order, and then K can go in 10 power 9 order, or specifically 8 into 10 power 9 order. That is simply 2000's cube. So K is very huge, and then X, Y, Z are also very huge. Correct? Make sense? Now, because only K is fixed, that means there can be multiple possibilities of forming S. If let's say, like I will give a very simple example. Let's say I talk about 12. If K is 12, then the dimension, one dimension can be simply like 1 into 1 into 12. Yes, this can be a good dimension, maybe 1 into 2 into 6. Yes, this can be a good dimension. So there are possibilities of forming the volume. By volume, what I mean is L into B into H. So the S box can have possibilities of length, breadth, and height because only K is fixed. Now, if that is the case, it very simply means you have to come up with an approach so that you're able to check for all the possibilities of different dimensions of S. Make sense? Is this clear? Now I'll talk about one extended idea to this. Now let's say that let's talk about this part only. For the first test case, it was given to you that they're choosing a side S. They're choosing the box S with the side 2, 2, 2. So just assume, like, let's say the outer box B, it had the lengths X, Y, and Z. Any problem? That's getting the problem. Now, let's say I have told you that the best answer will come from S by taking the side A, B, and C. I've told you this. Don't worry how this game will come to that part. Just assume this has already been calculated, that the best S is possible with the sides A, B, and C. Now, if I ask you, how many ways can you place S inside B? Can you give me a mathematical notation for this? What do you mean by best answer? All right. So sure, what do you mean by best answer is, over here I told you that S as a box has a volume K, which is fixed. Is it fixed that what can be the dimensions of S? No. So there can be various possibilities of dimensions of S, giving the same K as volume. Agreed? Yes, sure. Out of all such combinations, there is going to be one such combination which is going to give you the maximum number of distinct locations where you can place the box. Make sense? So let's assume, like, I'm trying to build your intuition. Like, what I'm trying to do is kind of a reverse psychology. I say that, let's assume I somehow found that best dimensions. According to me, the best dimensions were A, B, and C. Then the next question will be, you calculated A, B, and C, that's fine. Now I need to calculate this. All right, so people are giving this formula. Exactly. So there's a small typo, I think, above you did. This should be X minus A. All right, correct, which can be fitted inside the box. Exactly, sure. So if I've told you that A, B, and C are already given to you as the best dimension of S, then the number of distinct locations, that's actually your answer. Answer is going to obviously be X minus A plus 1 into Y minus B plus 1 into Z minus C plus 1. Does this make sense? Number of subarrays of K length per axis. Exactly. That's actually the case. So for every distinct tuple X, Y, Z, we have to add possible distinct positions. Not add, Sridhar, not add. You have to find for every distinct tuple X, Y, Z, not for X, Y, Z. Like, I'll try to come up with this ideology. First of all, agree to this part. Like, do you get this part? Okay, Sean is asking, how do I get this? Exactly. That's why I'm trying to build one thing. All right. First of all, let's fix that ABC was there. All right, Sridhar, it's fixed. ABC was the best S, best dimensions of S. Now I'll try to first show you this formula. Then we can actually discuss what the idea would be. All right. So how did I get this? How is it X minus A plus 1? All right, cool. Yeah, AS for ABC. Exactly, that's Sridhar. All right. So how is it X minus A plus 1? All right. So how can we actually imagine this? All right. All right, let's say that the outer box X had a value 5. And then the dimension you chose was 3. Any problem? Any problem? So imagine this part. I have an X-axis. On this X-axis, I will draw by blue the end point of the box B. So let's say this is 0, 1, 2, 3, 4, 5. So 5 length. Any problem? Any problem? Now with the red part, with the green part, I'll draw box X. So box S is with green, and then box blue was B. So with this, I'm going to draw this 3 length. This is 1 length, 2 length, 3 length. 3 length over here. And then this was the 5 length over here. Any problem? Any problem? Are you catching up till here? Just think about one dimension first. All right, one dimension. Now, if I'm talking about this one dimension, imagine this. There is a possibility to keep your box. There's a possibility, I'll repeat this, listen to this carefully. There's a possibility to keep the box S such that its length, if this is like, if x-axis I'm talking about, this is the length, then in x-axis, the length is placed like this. Then there's a possibility it can be placed like this. Then there's a possibility it can be placed like this. Agreed? Like you can slide the box in X how many times? 3 times or not? In X direction. Can you slide the box S in the total domain of B 3 times or not? It can be over here. It can be over here. It can be over here. 3 or not? Yes, Sean, can you imagine this? Everyone else, are you able to get this part? It's all about imagination. Like I cannot draw this variable on with the writing part or something. So yeah, all right. So I'll repeat this idea again. In the x-axis, if you think about one dimension, then the box S, the smaller box S, green box, can be slid over the B box 3 times. It can be placed this over here or over here. Now, if I ask you, directly tell me what is this value of placing it? How many possible ways are there to place it in the X direction? Then will you not say it is actually equal to 5 minus 3 plus 1? This is going to be 3, right? Or simply saying the length of the possible segment, that is this part. 3 possible cases, 3, 4, 5. Make sense? We can get all possibilities of dimensions as k-fix, store it in a set, and then iterate to see which has a maximum answer according to formula. Like, I mean, all right. So that is something that is an optimization knowledge. So let me come to that part. All right. We are obviously going to do this only, but we are going to do this in a smarter way, because the current thing you have told will get you a TLE. All right. So is everyone clear with this part? Why x minus a plus 1 for the x-axis? Yes. All right. Sean is clear. Is Sridhar clear? All right. Cool. Now extending to this, I did this for the x-axis. If I ask you for the y, for the z, will you not say this is going to be for y, this is going to be for z? Correct? Make sense? So if all the possibilities of placing the box S slidden on the y-axis is this, on the z-axis is this, on the x-axis is this, then the total possibilities by combinatrix will be this into this into this. Yes or no? Make sense? All right, Sean is clear, Sean is clear. All right, cool. So I think I have been able to clear this part up for you guys. Now comes the other part. I hope everything is clear now. Now the argument starts with the first question. We said that ABC was something I told you, take it as the best dimension. But now the question comes, how? How did you find this best A, B, and C? I need to find this. So now there is obviously one idea that was given by Shaurya that what you can do is you actually take up all the possibilities in some set or something like that. That's all right. That makes sense, and that can be one case. But then let's come to the time complexity of this. That's the smart part in this. If you look at X, Y, and Z, both are in 2000 order. Correct? So because both are in 2000 order, if you actually run a loop, you will require 3 for loops to find X, Y, and Z. And then inside this, you'll be able to check, is the multiplication equal to K or not? Multiplication, whatever you can call this, is it equal to K or not? Yes. Is this clear? This would be the ideal brute approach. But if you calculate the time complexity of this, you will see that this time complexity fails. You will get a TLE. Because this is a kind of a, like you can say 2000 into 2000 into 2000. That's the cube complexity, which is 10 power 9 order. So this is not going to work. That means we need a better approach than this. Now let's try to imagine. Our best case approach is if we are able to achieve a complexity below 10 power 8, we are good to go. Below 10 power 8 or a very, like, you can take much more warned statement, below 10 power 7. Below 10 power 7 is good to go. Currently, we are running in 10 power 9 order, which is not at all feasible. I want to remove that. So let's talk about the other part. I tried to find three variables, A, B, and C. If, let's say, I have A, I have B, then do I not have C? Do I need to iterate on C? Yes or no? Do I need to iterate on C? If, let's say, I have a A, I have a B, then can C's value be simply K by A into B? Make sense? So that way, what I can do is I can remove this inner for loop. This inner for loop can be removed. I can run an iteration on all the possible X, for every X, all the possible Y. And then inside that, Z can be automatically written as K by X into Y. Does this make sense? Yes. So this is what now our approach is going to be. What will I do? I'm going to run two loops. One is X, one is Y. And then the other value Z can be simply calculated by K upon X into Y. Or actually, this is A, this is B, and this is C. So C can be calculated simply by A into B. And then I can write very simple constraints on this. Now, what are the constraints? It's very obvious that A into B, K modulo A into B should be equal to 0. Like, you want C should be integer. This C should be integer. If C is integer, that means K is fully divisible by A into B. So this is condition 1. And then the other condition, when you divide K by A into B, it should be less than equal to C or not. Or not C, sorry, not C, Z. Because Z is your third term. If you get a side that's greater than Z, that means you won't be able to fit in the box. So by these two conditions, can you not very easily solve your question now? Does this make sense? Why LL long max is not working, but 10 power, this is what is working for question F. LL long max, yeah, exactly. LL long max won't work. I'll tell you why. I'll come in that part. I'll tell you why. In this, not in this, or in F. You're saying talking about F, right? We'll discuss question F. I'll tell you. Yeah, I'll tell you. I saw the approach. I'll tell you this. All right, cool. So is everything clear up till this part? So once this is clear, can we jump to the code? I think this is very, very, very much clear now. We can jump into the code. All right, cool. So I'll take the input X, Y, Z and take the input of K. Now take the input and make an answer 0. Now start off with I, or rather not I. In my explanation, I took this as A. So let me take this as A. A, then this can be B. B. Run an iteration A1 to less than X, B1 to less than Y. Two flags. If K mod A into B is 0, flag 1 is 1. If K by A into B is less than equal to Z, flag 2 is also 1. Now, if both flags are positive, that means this is a possible combination. Side 1 will be A, side 2 will be B, and side 3 will be K by A into B. Now, what is going to be the distinct places? That's X minus side 1 plus 1 into Y minus side 2 plus 1 into Z minus side 3 plus 1. And then maximize these distinct places with your answer. And then print your answer outside. So for all the possible combinations of dimensions of S, you very cleverly found out the number of distinct conditions. Please explain both these. All right, Abhishek, I'll repeat this again. I said that you iterated on an A, iterated on an B. So what will be your C? C will be K by A into B. Yes, Abhishek. Now C has to be an integer. If C has to be an integer, that means A into B has to fully divide K or not. If A into B doesn't divide fully K, then will C be ever be an integer? Make sense? So I divided, if I want to check is A into B fully dividing K, that means A into B mod K. So it's K mod A into B should be 0. This is flag 1. All right, cool. Any problem? All right. Now, let's say you find an A, let's say you find a B, and then you find a C. C is simply K by A into B. Then it can happen, no, that this C is greater than Z, which is the limit of your outer box in the Z direction. If that happens, will you be able to fit the S box inside? No, right? So this becomes my flag 2. Clear? Any problem? All right. Now, once this is clear, I found the answer, and this is when I can over. Now, what is the time complexity? By brute algorithm, it was very high. But now, it's simply X into Y. Yes? Which is, can we pre-compute factors of K and then take possibilities from these numbers only? Yeah, you can do that. You can definitely do that. Like, I mean, pre-computing the factors of K, this is going to take you like a sieve algorithm, like something like that. Because like, if you want a good time complexity, right? Sure. Or like for factors of K, even a square root, I think approach would work, because 10 power 9 square root will be 10 power 4 something, that also works. But then for taking the possibilities, yeah, you will have to run that loop and everything. That's also fine. That's also all right. You will have to, then you will only need 3 loops, right? Because you know the factors are going to be very low. Because for like a, till which question? We'll discuss till H1, Laksh. All right, cool. That's why my code word. Exactly. That, like, I'll give you a very simple approach. Like N, like I'll tell you why, like mathematically for a factor of N, like N has mathematically, it's not like, it's an approximation. N has N has a power of 1 by 3 factors. A number N will have 1 by 3 factors. Power of 1 by 3 factors. All right, cool. All right, that was told in the class. Works. So the time complexity for my code is X into Y. Now, what is the space? Obviously, I'm not taking any extra space. Am I taking any extra space? So space can be constant. All right, works. Now X into Y is definitely going to work, because this is going to give me a 2 into 2 into 1000 into 1000, that is 2000 square, that is 4 into 10 power 6 odd, which is definitely working. Yes. So am I good to go in this? Any problem? All right, fine. Let us discuss problem F now. All right, problem F. All right, so how many of you are able to solve problem F? All right, me, all right, cool. Didn't able to understand it exactly. All right, not able to understand it. All right. All right, cool. So let us read the problem. You are facing the final boss in your favorite video game. So enemy has a H health. You have N attacks. Ith attack deals AI damage to the boss, but has a cooldown of CI turns. Meaning the next time you can use this turn is actually X plus CI. If your current turn is X, each turn you can use all the attacks that are not currently on the cooldown all at once. So if you have some, let's say, attacks remaining with you and they're not on cooldown, you can use them together. That's not going to be a problem for you. Now it's saying if all attacks are on cooldown, you do nothing for the turn and skip to the next turn. Initially, all attacks are not on a cooldown. How many turns will it take for you to beat the boss? The boss is beaten when its health is 0 or less. All right. Cool. So this was like, now let's try to discuss one idea on this very simply. All right. There is some boss, you are trying to beat him, and it has some H health, you have some N attacks. And when you try to do that, you want some number of turns. Explain. Can you also explain question in your, can you explain question in your words also? Otherwise, explain question in your words also. All right, cool. I'll explain this question. There is a boss. All right. This is the boss. He has H health. Fine. Now you have total N types of attacks. types of attacks. So each attack has its given power and its given cooldown time. So let's say there are 3 attacks. So that means you have A1, A2, A3 as the power, or actually you can write like this, P1, P2, P3. This is the power of each attack. And then after you do an attack, you will have to wait some time in seconds. That time is a cooldown time. That is C1, C2, and C3. Any problem? Any problem, Yash? Now it's telling you that you are currently at 0 turn. No turn has been played by you. You move on to the first turn. And you say that now this cooldown time was actually like sort of cooldown turns. So what I mean by this is from 0 turns, that is you were having no turn currently, you moved on to the first turn. In the first turn, you can say that whichever of this attack was not in a cooldown, I can use that and I can hit my boss. So let's say initially I know that it's written in the problem, any attack is not in cooldown. So that means every attack can be used. So I can be very simply greedily and I can say very greedily, I can be like, let me use all of these attacks and let me like punch this boss with power P1, P2, P3, all the sum, and then his health decreases to H1 minus P1 minus P2 minus P3. Clear? Now, if let's say H health goes less than equal to 0, then your answer is 1. Because in 1 turn only you made your boss die. Clear? But what if that's not the case? Now, if let's say H is still left, that means you have to still hit him. Now your turn is 1. And now every power is used, so they have a cooldown power. So let's say if C2 was 2, this was 3, this was 1, that means after 1 turn only, or let's say I've talked about this P2. After 3 turns, now you can use P2 again. Before that, you cannot. Make sense? So if you are standing on turn number 1, when you will come to turn number 4, only turn number 4, this power will become active again. So now you can hit your boss with power P2. And again, it will go in a cooldown. So the question is asking you, like you took 4 turns, let's say you had to take maybe 7 turns, so on, so on, so on. Which is that 1 turn K, which is the minimum turn that before which you will not be able to kill your boss. At this, you will be able to kill your boss. So that best minimum K turn where you beat the boss. That's actually asked in the question. Any problem? Yes. All right, cool. Now let's try to build up an idea. I'll give you a very simple hint in this part. All right. Tell me, let's say, one thing is you can use no turns, 0 turns. All right. Correct. Then obviously you can use, there is a up there, makes sense that there is going to be an upper limit on the turns also. So this is the lower limit, LL. Or you can say low. Lowest number of turns you can use is 0. Any problem? And then highest number of turns is also going to be some number, which makes sense, right? After some number of turns, you know that the boss will die. Considering the constraints, like you can take maybe very, very high turns, like maybe 10 power 10 turns, example, or 10 power 10, 10 power 12 turns. In 10 power 12 turns, if you hit this boss, in 10 power 12 turns, it's for sure he will die because the H is only in 10 power 5 order. It's very small as compared to 10 power 10. Make sense? I mean, all I'm trying to tell you is there is obviously going to be a high limit to this. So let me call that high limit as a H. Oh, sorry, not H. Let me call this as R. Any problem? Any problem? Now I'll say 0 was a possible answer. R was a possible answer. 1, 2, 3, 4, so on, so on, so on. R minus 2, R minus 1. This is the number line. Now, if let's say I tell you by fact that in 4 turns, you will be able to hit your boss. Or sorry, finish your boss, destroy your boss, kill him. In 4 turns, it is possible to kill your boss. Then tell me, will it be possible to kill your boss in 5 turns, 6 turns, 7 turns, and so on? Yes. Yes. Correct. If answer for 4 That is, will the boss die in 4 turns? If the answer for this is true, then any value above this will also give you true. Make sense? And then if I say that for this 4 turns, answer was false. If let's say I say that the answer was false. Let's say that answer was false for 4. Then do you think you will be able to kill the boss any turn before this? If 4 turns you were not able to kill the boss, how will you kill them in 3 turns? Not possible. Not possible for 2 turns, not possible for 1 turn, and definitely not possible 0 turns. Make sense? So what can you identify in this problem? Can you see, like all those who are familiar with this idea, can you see a monotonic predicate nature of the answer? That is number of turns. Yes, meaning I have a low end of the answer, I have a high end of the answer, and the answer is following a monotonic predicate state. So can I not run binary search on the number of turns? Is this the wow moment? Yes. Make sense? Can it be done using priority queue? For priority queue, like I did not think what the time complexity is. Like my first intuition was actually priority queue only, sure. So like I am not sure that priority queue will work because the time complexity of actually pushing back and then maintaining this is going to be very hectic. Because like why the problem would be, what if your AI and CI are very small? Like for this only, see over here, you have such a big number of turns. Can you see this answer? This answer, to calculate this answer, you will actually push and pop so many times that your complexity will actually go very beyond. This is what I'm expecting. Like, I'm not saying for sure, all right? So the binary search is like the very classic solution to this problem. Again, I think maybe priority queue can be used. Maybe it cannot. I did not give a very good thought on the time complexity. I got TLE that right. All fine, sure. Then it clears the approach, right? I always thought my geometry was weak, but then today that's not a problem at all, really. Yeah. So everyone is learning over here. Everyone is gathering new ideas. I would be very happy if you actually get this idea and you implement this later on in any problem. All right. So currently the question should be, did you get this? Do you get this idea now? Why binary search? Clear? All right. Now, if it is clear that I want to run a binary search on the turns, then by logic, it means binary search is going to run in a log n complexity, a log of search space, whatever the search space. So I say search space from 0 to this, whatever R number, R is very huge, but whatever that be the case, log of that is going to be the binary search complexity. Now, binary search in itself requires a checker function. Like if you're standing at this number of turns 4, I obviously have to ask you this. No, that fine, you were standing at 4, but how did you get it true or false? Tell me how do you, why are you saying in this turns it was possible or not? You will have some checker function to actually report whether it was true or false or not for this 4. And that checker function by logic, if you have implemented, like if you have done such problems, if log s term has already been declared or log search space has already been utilized, you would want that the checker function now runs in O of n complexity, so that your overall complexity looks like an order of n log ss complexity, something like this, which is definitely going to work because n is an order of 10 power 5. Yes, and ss is going to be like log of s is going to be barely like 30, 40, 50 terms maximum. Log base 2. This is log base 2, if I'm not clear on this part. All right. So that means all we are left to do is actually implement the checker function. If you are able to successfully implement a checker function in O of n complexity, then I'll be good to go on this binary search. Make sense? I will run a binary search, calculate the mid. If this mid gives me true, then I will store this mid as an answer and shift my h to mid minus 1. Else, I will shift my L to mid plus 1. Clear? Now, how do I form the predicate function? Sorry, the checker function. Now, one thing is very obvious. They give you in the hint only. If something is not in cooldown, you can use it all together. So at initial turn, every turn is not in a cooldown state. Correct? So by very greedily, can you say that the best turn, the first single best turn you make can be very simple, take everything and attack your boss with all the n attacks. Make sense? I'm trying to picture the implementation. I know there can be a very mathematical implementation to this part again, but this is something I had intuition. So I'm directly implemented it out. All right. So what I did was I simply said, the first turn is my best turn. My first turn is my best turn. In this turn, I'll use all the n attacks and simply make my boss die. So my boss dies and, sorry, not die, sorry, make my boss's health low. How much low? H minus sum of all the array. That is AI. And now every attack is under a cooldown. Make sense? And 1 turn has been used. Now I will run a binary search. I am going to run a binary search from 0 to a high limit. My limit is actually 1E18. I have taken this limit. All right. Why I have taken this limit, I'll tell you. All right. And then in this, I'll find a mid. And then I'll argue. If you had mid turns available with you, how much damage can you give H? Or sorry, to the boss. How do I calculate that? If let's say you have a cooldown time, BI, and you're talking about mid turns, then will you not be able to damage your boss by mid upon BI into AI? If I'm talking about an ith attack, in mid number of turns, since every turn is in cooldown, from that cooldown state, every BI number of intervals, that ith attack will come into activation state. And how many attacks will you be able to make? If BI is the interval of its topping, then mid turns upon BI turns is going to give you the number of turns in which this ith attack is active. And in this active state, you can multiply that with the power of your attack. That's AI. Or that's PI actually. And this was actually CI. Sorry, in my previous analogy, right? CI and BI, something like that. Yeah, CI, PI. So for an ith attack, this is going to be the damage I can do to the boss. And now can I calculate this for every boss? Sorry, for every attack. If I calculate this for every attack, sum it up. Let me call that S. And then when I decrease S, that means I make H go by S again. And then if this value goes less than equal to 0, will I not say my boss has died? Is everyone clear on this? Yes? All right, cool. So this is the whole idea. So if I say H minus S goes less than equal to 0, that would mean that my boss has died. So this mid turns is beneficial for me. Cool enough? And then what is going to be my answer? Whatever mid I find, like whatever best mid I find, +1 is going to be my answer. Why +1? Because this 1 turn is this turn, no? This first turn you actually took. Make sense? Can we move on to the code? All right, cool. So I took the input H and N, took the input of the array A, took the array input of the array B. That's actually P and C. Actually, you can, if you want, you can. This is P, and this is the array C. All right. Now I say that first I'm going to greedily decrement by my boss's health by PI. That's my first attack. If in doing so, H goes less than equal to 0, I will print 1 and continue. Because I took only 1 turn to fully defeat my boss. If that was not the case, I'll take an L, take an R, take an answer, run a binary search, calculate a mid, calculate an S. How? S plus equal to mid by Ci into Pi, as I showed you over here, for each ith attack. If H minus S is less than equal to 0, I will make my answer as mid and R as mid minus 1, because I want more mids which I can find, if that is true, because I want the first true, right, from the left-hand side. Else I will do mid plus 1. And then the answer that I will print will be answer plus 1. This 1 is actually the number of first turn which I utilized to decrement my H. And then whatever answer came, best other possible number of turns. All right. So R equals to 1E18 is working, but my R 1E17 is not working. RE 117 is not working. It should work actually. I mean, like, let us see your code. You're getting a very different answer, right? This one. All right. I mean, like there could be some implementation difference. Like, can you see this implementation? Like, maybe you can get this part. I mean, this is again for a doubt support part. Like, for the video purpose for PCD, I think I should not invest that time over here. You can paste your code in the chat if it's possible. Let me see if in quickly I can identify some error. All right. So till that point, is everyone clear with this? Yes. Now, if I actually run this complexity, this is going to be log base 2 of 10 power 18, which is actually something like 60. All right. And then this inner checker loop is actually O of n. So overall time complexity is going to be n into log base 2 of 1e18. And then what is the space? Space is obviously going to be O of n because you're using some extra space to store your array. All right, Pi and Ci. Is the approach clear with everyone? Can I move on? Hello. Couldn't reach to DH with a lot of implementation errors. Should I watch approaches now? Should I wait first attempt it independently? I mean, you can attempt approaches like that's. You can watch approaches now. Like if you have done so much on right? So Vishwas is saying move on. Cool. Let's try to move on. Okay, you have money 18 as long, then mid sum is getting added. Health is less than sum, return true. AC health. All right. All right, so things kind of look good over here. It's 10 power money 18. Yeah, this is 10 power 18. Starting off with 1. You are getting a wrong answer or what? Like, what are you getting exactly? You're getting a wrong answer, right?
सिर्फ एक टेस्ट केस पे रॉन्ग आंसर आ रहा है फिर
So,
मैंने इसको फिक्स कर दिया इफ हेल्थ इज लेस देन एक्यूमुलेट करके तो इसका तो आंसर 1 आ गया लेकिन रॉन्ग आंसर एंड टेस्ट केस 2 आ रहा था सेम मतलब एक 6 था उस पे आ रहा था मतलब 1 का एरे था और उसका एलिमेंट 6 था
तो दैट मीन्स इस अप्रोच में प्रॉब्लम है, राइट?
हाँ
तो that clears up one part, right? Like the idea which I took over here, I separated the first turn with the other turns, right? So that works.
ये मैंने 10 to the power 16 यूज किया था उसके बाद मतलब ट्राई करने के बाद थोड़ा सा 10 to 17 पूरा गया 16 पे चल रहा था तो वो सबमिट कर दिया तो पता नहीं क्यों 17 नहीं चल रहा और मिड भी मैंने स्टार्ट प्लस एंड माइनस स्टार्ट बाय 2 किया है मतलब ओवरफ्लो का भी कोई
That's all
प्रॉब्लम
right. That's all right. Okay. So I'll do one thing is you can raise this in the
Excuse
doubt
me.
support, all right?
Actually, search space
ओके
गलत लिया है इन्होंने.
Okay,
Search
search
space.
space गलत.
So जो possible zero है answer like first turn as in है ही नहीं तो इसलिए he is getting wrong answer in that 25 and if you check the expected output and the
That
received
also makes
output.
sense, yeah. I mean, देखो यहाँ पे when you do health minus accumulate this part, right? If health goes like search space starts with 1, that also doesn't make sense, right? As somebody is pointing
नहीं
out.
एक टेस्ट केस में आ रहा है आंसर जिसमें 1 आ रहा है सेकंड लास्ट
Okay,
वाले
fine.
नहीं
So
हाँ सेकंड लास्ट वाले में
let us do one thing. Let us do one thing. You can raise this in the doubt support. I'll take this personally. Okay. Raise this in the
ओके
doubt support. I'll take this and then we'll discuss this. All right.
ओके ओके
Cool. It's
Yes.
great that you got the idea. All right. Like don't worry about the ratings in this part. If you get the idea that you have to imply binary search and everything, that's all right. Implementation
Okay.
comes secondary in this part. Cool. All right. Let us move on. Problem G. All right. Now this problem G is something I have done I should say a lot of observation in this part. All right. Now, I haven't still been able to come up with a mathematical exact approach to this. Like, I know what's the mathematical logic once I understood that this is what I had to print. So I will try to share you with that part, because I am not myself a very high rated coder otherwise. So that I need to like tell you why, like how generally coders or like 1800, 1900 coders can think, just to get the problem out of the way in the contest. All right. Mathematical proof will be definitely there in the editorial part. So you can definitely look up that part, like why exactly that would be happening. I'll try to come up with few observations and approaches, why I did this and why does this make sense for me, or at least it made sense for me. All right. Is this clear? So let us try to discuss this problem. All right. First of all, when I read this problem, it's very obvious for me that L and R are very huge. So let's read this problem. Dn is represented as the sum of digits of n. And you have to tell how many integers n where 10 power L less than n less than 10 power R satisfy this case. That is, d of k into n equals to k into dn. And then you have to output the answer 10 power 9 plus 7. So whatever this equation is given, forget this part. Look at the constraints. Now, because of this constraints, L and R are very huge. So it's very obvious you cannot iterate. You cannot iterate on the possibilities of 10. Correct? And then K is also very huge in 10 power 9 order. That means very simply, it's very simple that your time complexity is almost constant. It has to be very next to constant, like something in a log power or in a constant power. Make sense? Is this clear? So by looking at the problem, I was very clear that I have to come up with a constant approach, constant time, or a log time. Correct? Clear? Now, the other thing that I looked at this part first of all. There was this case given, 582, and then there was this case given. Now imagine this, that you are talking about 10 raised to 582. And then you're talking about 10 raised to 74663. Correct? Make sense? And in that, you're talking about 3. The answer is not very huge. I mean, it's obvious that the answer might have come out huge and that it was modulo 10 power 9 plus 7. But then it was not very huge. Otherwise, for me to what would I understand is, if I want a constant time complexity and I want something to happen in log, or constant or log, then my idea was, what if I can find a pattern or an observation so as to make myself aware of what can be the possible answers? How do they look like? Like over here, they only give you for the first and second test case. Yes, and on the third test case, they said everything from 10 to 100 is possible. Correct? So what I thought is, let me do something. I know I can write a brute force solution. I know it is not going to work, but if I give it very low constraints, it is going to work. So my ideal approach, like this, I'm telling you, this is a very coder perspective. What you can do is, in problems like this, try to print your answer and see you can find an observation or not. So this is something what I did. I said, all right, let me try to give it some small constraints. Let's maybe keep L and R to be like 0 or 4 or something, or maybe like a very low limit, like less than 5 limit. And then K is going to be like very small, like 1, 2, 3, 4, something like that. So I'm going to iterate like 1, 2, 3, 4. I'm going to check for cases. And then for that, I'll try to print what answers are coming or not. All right. Is this clear with everyone? What I just said, told you right now. Is this clear? All right. So now what did I do? What did I do actually? I'll show you in the code part only directly. All right. Forget this order, right? Forget this for now. And then what happened over here? Let's just talk about this. I took L, R, and K. And then look, I have written over here a function for you. That's the sum of digit function, basically, simply to return you the sum. So what I did was, let me actually try to calculate answer. So I will make my like long I equals to power of 10 comma L. Then I'll take this I less than power of 10 comma R, I into I plus plus. This is going to be I plus plus. And then what I'll do is, I'll say, if my as expected, if my SD of I into K is equal to SD of I into K, then I'll print I. Any problem? All right. Now try to observe what part. All right, I'll remove this test case. Like this test case is not currently of my use. This is the other test case I created for my testing purpose. So later. So let's try to observe. Let's say I take a small part, so like 0, 4, and I took something like a 5. All right, let's print. The possible numbers, which were the answer, looked like this. Any doubt in this? It looked like this. All right, it just popped it up. Now, what I was doing is I started incrementing k, and I said, all right, it starts with 0, 4, goes to 6. Can you see that the answer of 5 and 6 were same? Let me actually take this a bit small. Let me say 0 to 3 only. Now observe. Answer from 0 to 3 for a k6 is this much. Make sense? Now for 7, let's observe. Same. Let's say for 8, it's going to be same. For 9, it's going to be same. And when I did 10, it vanished off. No answer. And then I started off with 5 actually. So for 5 also, I was receiving the same answer. And then when I went below 5, that is when I went to 4, my answers changed, possible answers changed. And then I went to 3, my answers changed. When I went to 2, my answers changed again. And when I went to 1, my answers changed. So my observable notice was that I have no answers that are coming for k greater than equal to 10. If I take any L and R for greater than equal to 10, I have no answer. Then for k greater than equal to 5 and less than 10, I have some answer which is fixed. As in, if you take k equals to 5, 6, 7, 8, or 9, answers are going to look same. Then for k equals to 4, there was some other answer. K equals to there was some other answer. K equals to 2, there was some other answer. And k equals to 1, there was some other answer. Any problem in this part? Like all of this is observation and brutally doing what I wanted to do. Just to find observations, just to find maths. Any problem? Now, obviously, I tried to argue. Like, I cannot obviously check till infinity for k. So I argued myself that after 10, I like checked for even 12, 13, 20, 30, 40, even 100. And I was not getting any answer. I was getting 0. So I argued myself, why? Why is it happening? Basically hacking your account. Exactly the kind of that part. Like, why am I doing this? Is because, like, for a very formal proof, there is going to be the editorial. For a very intuitive and a hack-based proof, this is going to be PCD. That's the difference. That's why you are watching a PCD, right? You want something in a sort of a hacked perspective. How did you come up with this part? Why do you think this works and so on, right? All right. And then obviously I tried to prove it. Like, I'm not simply saying do this blindly. I sat with the pen and paper myself, and then I tried to prove this. Why is this coming? Like, why is this output? There has to be some reason why this is happening, right? So my logic with this part that you had to calculate d of k dot n equals to k in dot d of n. Make sense? Now, when k was greater than equal to 10, your answer was becoming 0. That means you were getting no answers. Let's talk about k equal to 10 only. All right. What is the physical meaning of saying k into n? Tell me this part. If you place k as 10 and if you have a number n, then all this is going to do in the digit, is it going to change it? Imagine if n was, let's say some number 17, let's say. Then the sum of this is currently 8. If you multiply this with 10, it is going to be 170. And the sum is still going to remain 8. Because all you added was a 0 in the ones place. Correct? All you added was a 0 in the ones place. Is this clear? So k into n is going to give you, like, this thing is actually d of n only. Agreed or not? Agreed or not? For k equals to 10, like I'm talking about k equals to 10. I did not say for k equals to 11 for short, k equals to 10 for short, 12 for short. For k equals to 10, this is correct. Make sense? So for k equals to 10, this term is actually simply d of n. Now tell me, is this equation correct? D of n is equal to k into d of n. Is this possible? No. This is not possible. Yes, this is never possible. So by this logic, can you not intuitively think that for k equals to 10, it was not possible? Why? Why was it not possible? Because what was happening was, or what would have happened was, you would have just, if you multiply k into n and then find the digit of sum, that would simply mean you're shifting n to the left side to create some extra spaces. That's all you're doing. And then you're finding the sum. But when you do k into d of n, you are actually finding the digit sum of n and then multiplying k into it. And remember, k is a number greater than or equal to 10. Then can you not imagine this part, that for such a large number, k greater than or equal to 10, by this logic of k equals to 10, because this equation is not getting satisfied, for k greater than or equal to 10 also, this will never get satisfied. Can you get this intuition now? Yes, makes sense? Now have I proved this? Like I know I have, I mean I know this is not a very exact paper-based proof. You will get a better approach in editorial for sure, but I wanted to tell you something I thought in myself for the contest. All right. Cool. All right. Any problem in this? But for 11, 12, some can change. Exactly, it can change. But let's talk about that. Like I tried to print it. Like I did not say it directly. I had the code written over here. So I tried to take it. Like I took k as something huge. Like see for this only. Let's say you have 11. You will see no answer comes. No answer. See? And why would that happen is very obvious. Like you have over here 11 that is getting multiplied to the digit sum. And over here, you have multiplying 11 first in n. So it's kind of shifting the places, creating an extra digit for you. That's all. Let's try to think it that way. All right, I'll give you one more idea in this. 10 plus 1, can we argue it like that? Exactly, like that was my argument exactly. Like, let's argue it like this, that d of n as a number, whatever this number is, if you multiply it with a number k, which is giving you, which has a value greater than or equal to 10, then this d of n itself will get shifted. Yes, whatever, let's say currently it had 3 places, then it will now have 4 places if this number is greater than or equal to 10. Agreed? Or 5 places, 6 places, so on. Because k is the number you're multiplying. But on the other hand, if you multiply inside and then find the digit sum, this never guarantees you that you are going to get 4 places now. This will still make you get 3 places only. It kind of makes intuitive sense. Because you know that I am multiplying inside and I'm then finding the sum of digits. And sum of digits intuitively are not going to go very huge. Agreed? Makes sense? I mean, this is all about hit and trial. You can see like I also had wrong answers, right? I also had wrong answers. During contest, I was not able to come up with a very bilkul pakka proof type of something like that. But it's fine. Like this is something that has to be come by observation and stuff. Something has to be tried. You cannot just idly sit in the contest. All right. Make sense? So for k greater than or equal to 10, I was getting an intuition that no answer would exist. Because I would shift n, it would create a place, but then sum would not go very huge. Either way, k multiplied outside would create a very huge difference. So L and R, like LHS and RHS won't match. So for grade equals to 10, I was not getting any answer. I did very long brute approach in this over here. Did like 10, 12, 13, 14, 20, 15, 20. So many k terms. I was not able to get an answer. So I very riskily said that for k greater than or equal to 10, I will print 0. Whatever happens next, I'll see. If it doesn't work, it doesn't work. Fine. All right. So this condition popped from there. If k was greater than or equal to 10, I'll print a 0. Now I had expanded this in the other part. I said if k is greater than or equal to 5 and less than 10, then I was getting very specific answers. Let's say this was 9. I was getting very specific answer. And let's try to look at the answer. What I was getting over here. Can you count this number of answer? This is 1, this is 2, this is 4, and this is 1 again. I'll try to actually expand this also. Let's say you try to calculate for 0 to 5. Then also the answer was coming same. As in like same otherwise. What I saw was you started off with 0. Let's say you actually did not start with 0. Let's say you start with 2. Then look what is happening. When you started off with 2, what happened is you had all the 3 placed digits, then all the 4 placed digits, then all the 5 placed digits. And if you count them, they were coming out in order of 4. Then this was total 8 and this was 16. If you would have started off with this 0, you would have actually 1, 2, 4, 8, and 16. This is 1, this is 2, this is 4, and this is 8, and this is 16. What does this mean? Like I'm having a pattern over here. Basically, in powers will be reached. Exactly. That's the case. Basically, we are having some powers which are getting intuitively. So if let's say I want a constant approach in this, can I not say for like k equals to, like for k greater than equal to 5, I was having answers like this only, which indirectly told me I have 1, 2, 4, 8, and 16, which means I kind of have a GP. I kind of have a GP of 1 plus 2 plus 4 plus 8 plus 16, so on. Do you get this part? This is direct formula, right? This is direct formula. Exactly. Now, if I have a GP over here that is extending from some part to some part, can I not do this, that I find the sum of GP till R terms? I find the sum of GP till L terms. And then R terms answer minus L terms answer is going to be my answer. Does this make sense? Yes. So this is what I did over here. Now, to actually calculate this, like if you calculate this GP, this is the sum of GP is actually A into R power n minus 1 upon R minus 1. Now, A over here is 1, R over here is 2. All right. And n over here is actually either you can take this first as R, and then either way you will take this as L. So A into R power n minus this would be actually for this part, this is 1 into 2 power n minus 1 upon 2 minus 1, which is simply 1 only in the downside. So this is simply 2 power n minus 1. So this is 2 power R minus 1 for R terms, 2 power L minus 1 for L terms. If you do 2 power R minus 1 minus 2 power L minus 1, this gives you 2 power R minus 2 power L. This is all we had to calculate for k greater than equal to 5. Now, to calculate this, again, you have very huge power. See over here, L is in 10 power 9 order. So can you calculate 2 power R if you iterate simply in L or R? No. Can you do that? Because it's 10 power 9 order, you will require a for loop. It's going to be a problem. So this is where some advanced use cases come into picture. There is something known as binary exponentiation. Are you aware of this? Or modulo binary exponentiation. So I will say that I am going to use binary exponentiation to calculate 2 power R. And then similarly calculate 2 power L. And then I am going to run, because again, I'm talking about I also want the answer to stay in the limit of 10 power 9 plus 7. So this is actually not going to be binary exponentiation. You can call this binary modulo exponentiation. So you have to also pass this 10 power 9 plus 7 in this. And then when I actually do that, I'll calculate 2 power R, 2 power L. Then I'll run modulo subtraction in this. Modulo subtraction means 2 power L mod M minus 2 power L mod M plus M whole mod M. This is modulo subtraction. Like modulo subtraction is like A minus B mod M is actually equal to A mod M minus B mod M plus M whole mod M. So this is modulo subtraction. Here R is greater than or equal to N, so no need to add M. Yeah, I mean, yeah, that also makes sense. I had a function written in my template, so I use that. Even if you don't do that part, that's all right. Because you know A is definitely greater than B. So this term is never going to give you a negative term. But just for the writing purpose. All right, sure. Cool. So this was my observation for k greater than or equal to 5 case. So that is why I wrote something like this. I said, if k is greater than or equal to 5, that is else if, is k greater than or equal to 5, find ls, that's power mod, that's the function I wrote. Power mod is the binary exponential function, 2 to the power of L with the number M. M is actually this number. M is the big number, 10 power 9 plus 7. That was there. You can declare this otherwise also. Again, this is the code I was not able to clean because I had to take the PCD. But in the description, I will attach the code with a cleaner structure So for any beginner who's out there who's seeing this video, don't worry, you will get the clean code in the description. All right. So this becomes 2 power L, 2 power R, and then module subtraction, that is RS minus LS with the M part. So this is mod subtraction function. This is again a template I have called. I can replace this with the correct part, but just for namesake, understand this is what it is doing. Any problem? Any problem with this? Now, up till here, I have made a lot of observations. Now, because I had made a lot of observations, I had like invested around like 30-40 minutes into this part. I was totally into this, and I'll solve this problem. Somehow or the other, I have to solve this problem. So I started making more observations. I said for 5, greater than equal to 5, it seemed very obvious that this is the case. For greater than equal to 10 also, I have risked this part that is going to be 0. It's obviously going to be 0, otherwise only because I thought, yeah, that works because of the digit function and everything. So I tried next cases. Now I talk about small cases. 0 to 3, I was calculating for 4. Now for 4, I had again an interesting observation. You can see over here that I had 1, 2. Then, I had all the digits over here, only 0, 1, 2. Can you see any digit 3, 4, 5, 6, something like that? No. All the digits are ranging from 0 and 0, 1, 2. And then the answers are kind of changed. First, the set collection is 2. Then the set collection is actually 6. Then this set collection, if you count this, this is actually going to come out as 18. So indirectly, what was happening is, like, if I now try to find the sum, it was for k equals to 4. It was coming as 2 plus 6 plus 18 plus, and like if you do this yourself also, you will find that the next answer that would have come would actually have been, this would be 54. And so on. Exactly, 3 ratio. That was what was this part actually? If you take 2 common out of this, take 2 common, this is actually 1 plus 3 plus 9 plus 27, so on, so on, so on, plus 81, so on. So this was actually a GP of 3 getting multiplied with 2, which is actually like 3 power 0 plus 3 power 1 plus 3 power 2 plus 3 power 3, so on, so on, so on. So if you find the GP of this, some GP of this, what will be that part? A is 1. So 1 into 3 power n minus 1 upon 3 minus 1, which is 2, into 2. So this 2 and 2 gets cancelled. What are you left with? 3 power n minus 1. Calculate this for R, calculate this for L. Simply print 3 power L minus 3 power L. 3 power R minus 3 power L. So this became my next observation. I said for k equals to 4, answer, like, again, I'm trying to kind of whisk away in the problem, but then I can guarantee you this, like I have done this for, like, I ran this for how long only I know. And I came up with this, that yes, it is actually working. For this, the answer is actually looking like this. So that is why I said, let's risk it. If k is equal to 4, I'm going to print power mod in 3. 3 power L, 3 power R, do a subtraction mod. Now let's see the answer for 3. If k was 3, now an interesting observation again. Now answers look like 3. Then I had total answers as 12. Then I had total answers as 48, which was interesting. What is this pattern now? If k is 3, then I had 3 plus 12 plus 48. And so on, so on. I counted later on. So this was actually, if you take 3 common, 1 plus, this was coming as 4 plus 16 plus so on, which means it was actually a GP of 4 multiplied by 3. Which again would have given you an answer that looks like 4 power R minus 4 power L. So this is the observation I had now done for k equals to 3. Similarly, I did this for k equals to 2. Over there's an observation of 5 power. And then in the last part, that was if k was 1, observation for was a 10 power. If you take k as 1, that is simply saying every answer is possible. That would mean you will have a 10 power. Any problem? And now this code actually ran. This code ran for the highest test case also. It gave me a correct test case on this part. And it's fairly obvious that if you're able to get an answer for, like, okay, I need to remove this. If you get an answer for a very high powered test case like this 582, 74663 and so, it's like kind of obvious that it's going to work. Make sense? Now, I actually looked up the other codes also of the other people, and many of them have actually done this in a shorter mathematical formula, right? By this approach, what you can actually deduce over here is, you can do something like this by saying that I will take, like, over here you can see I am doing this thing a lot of times, right? So the other approach was like, if you boil this down in a very formal approach, you can actually write this as the number you want to insert. Let's say that number is Q. That Q number, 7 minus K. No, actually, it was kind of like something like 10 by K, right? 10 by, I mean, again, formula can be anything, 10 by K. And then there was a check that if let's say you still feel that I think 10 mod K was a value greater than 0, then you will increment Q plus plus. And then all this part can get boiled down and you don't need to write this. And you can just replace this with a common factor that is going to be Q. I think this works, not wrong. Yeah, works. All right. So again, like, I'm very sure that people who might have solved this problem, if they are able to see this mathematical approach, maybe that's all right for them. But I wasn't able to see that part directly. And that's what the whole point is about. Like, it, according to me, this was a very, very observation-based problem. I mean, at least for how I did this. And later on, you can obviously boil down an approach to a lot short part. That's just optimization, right? I thought about this, but not able to code it. All right, cool. That's great. So like I have had a lot of, like, I have done this many times, this hacking sort of a structure. I've done a lot of many times in many problems. So it's kind of an experience for me, right, to do this part, but then it's all right. Like I was trying to come up with observations, right? And you get this logic that you have to somehow come up with a constant or a log in complexity. For that, either you are a very smart genius and you come up with a direct mathematics, which is very, like, I'm not saying you cannot. I was just not able to do this in contest. And it's fairly obvious for me to assume that many people will not be able to do that part. But what we can do is actually print out in a brute manner and actually try to observe why your formula might work or what formula can you come up with. That is something you can, everyone can do. It only is going to take some time and some energy, some pen and paper, correct? So this gives a mental note for you. Like never, like, you can actually solve problems like this in this manner so that you can actually take small constraints and try to build a larger picture for yourself. This is what I did in the contest. All right. Again, you will find a very good observation editorial in the solution itself. So most of you there would have given a very good formal proof why K greater than 10 is like this, 5 is like this, 4 is like this. That's all right. All right, cool. Is it cool with everyone? Now, what is the time complexity of this? The power mod function actually runs in whatever power you pass to it. So it's actually going to run in log of y. Log of L over here. That is the power you want to raise it with. Similarly, this is going to run in log of L, log of R. So that means this is done like everywhere. This is done in if else check only. That means your overall time complexity of this code is actually going to turn out as O of log of L plus log of R. Now, whatever is the bigger term out of this, obviously, I think R is going to be bigger. Yeah, R is going to be bigger. So you can write that term. And this complexity definitely works. Any problem? Using int32 instead of int10 will not lead to some issue. No, it will not lead to some issue. This is like a standard thing many people write. Because I mostly don't use int, by the way. So I actually typecasted int to have a long structure. We can move forward. All right, sure is saying we can move forward. I think it's clear for everyone also, right? And for everyone watching the video. Cool. So let us move forward to the final and last problem. Now, this problem is actually a very good problem. And this is not at all something I can improve. I'll prove this in everything. All right. So maximize the largest component problem. First of all, did you guys read this problem? Like, did you come to this problem? No. All right. No. Cool. So actually this problem is not for beginners. I'll say this very straightforward. Why? Because this problem can be solved by a data structure, and that data structure is something that is not taught to beginners. That data structure is called disjoint union sets, DSU. All right. Now, once I'll tell you why the data structure has been used, and it is necessary to use that. So you don't need to understand the inner lying of this data structure for this problem, at least. All right. How is the data structure working and so on? This can be a new problem for you itself to actually learn one of the use cases of that data structure. that pruning of path. No, not at all. DSU is a data structure itself. It's not like pruning or something. It's a data structure. All right. First of all, we have to I'll try to cover up some quick concepts in this part so that because it has graph prerequisites. All right. So you need to have some knowledge about graph. If you don't, I'll try to give up a good idea on this part. All right. So let us read the problem. Alex has a grid n rows and m columns consisting of dot and hash characters. A set of hash cells form a connected component. If from any cell in this set, it is possible to reach any other cell in the set by moving to the another cell in the set that shares a common side. Now, the size of the connected component is the number of cells in that set. Now, do we understand what is the connected component? Any idea to this? Yes. All right. People are saying yes. Yes. So let's actually give a quick demo over here. If let's say I tell you which connected component this hash belongs to, you will say this connected component belongs to the hash, these two, and this one. These three hashes together form a connected component. Yes. Am I correct? Why? Because all of them share a same side. From this component, this hash, you can go to this hash because it has the same side. From this to this, you can go this side. This has the same hash. Make sense? Correct? So we all understand a connected component. Now, what is Alex doing is, in his operation, he is having the power to convert any row or any column to all hashes. And when he does that, he is asking you what is the maximum possible size of the largest connected component. So let us try to see this. They have given you 4 test case, and they have said if you convert the row 4 to hash, you will have a component 11. How? Let us see. This is the 4th test case, and this is the 4th row. Currently, it is all dots. If imagine I convert it to all hashes, what will happen? This is a hash, this is a hash, this is a hash, this is a hash, this is a hash. So I have 5 hashes. Are you all following up with me? 5 counts. Then this is connected to this hash. It has a common side, so 6 hashes. Now this has a connection over here, 1 hash, 1 hash. This is also connected. And then this 3 hashes are also connected now because they are in a same side, which will be connected to this dot, which now is a hash. So can you now count 1, 2, 3, 4, 5, that's 9, and then 2, 11. Can we all count 11 now? Does this make sense? Yes? Exactly, like kind of that part. All right. Cool. So I think this is clear with everyone. Now, obviously, there's going to be one thing. You know that if you are given the power to convert, is it like represent graph by matrix, then use disjoint? Exactly. That's exactly the case. Exactly the case. Not DFS, not DFS. That's what I was coming to. All right. Cool. So let's say I take up this row 4 and I convert this to all hashes. Then my current component size is going to be 5. That's very obvious. Is that right? Current component size is 5. Now, to this component, anything that is connected, first of all, try to look this, like, why can I not zoom beyond this? Yeah, I can zoom. Yeah, look over here. If I make this all as hash, then tell me, this row has become all hashes. Any component that adds to this row is either going to be present in the row above or in the row below. Yes or no? That means, like over here we saw, if I convert this to all hashes, I have a connection over here. Can you see my mouse? Connection to this. This is a hash that was connected to this blue row. Then this was a connection, and then this was a connection. So only above and below. That's the only case if I'm talking about a row. Correct? Now, added to this part, if now I give you the approach, I say what you can do, go to every row, take that as a converted hash, and then from that, from every cell, run a DFS or a BFS that expands to its top and bottom margins, and then find how many hashes can be translated, or sorry, not translated, covered or visited. Then you will get the answer for that particular row conversion. Make sense? If let's say I'm standing at this row and I'd say you, all right, from this cell, run a DFS. Sorry, run a BFS. Expand in the above and top manner. find everything possible. You will say only I'll find this hash and this is I'll stop. For this find, no hashes. For this find, no hashes. For this find, all right, I found one hash, then two hash. So two get answer. For this, you will find 1, 2, 3, 3 hashes. So you can run a BFS sort of an approach with every cell in this row, and that's going to give you an answer. But do you think that's going to give you a correct time complexity? You will have to go to every row. And for every row, you will have to go to every cell. Then run an DFS. Now that would mean for every cell, you are running a DFS. Now DFS has a time complexity of V plus E. Correct? DFS has a time complexity of O of V plus E. Now in this case, V plus E simply means BFS will have a complexity of N into M because you are talking about a grid. That means you can visit it, or you can visit all the cells, right? It is a possible case. So for every cell, you will run such a complexity. Every cell is N into M. Again, N into M. You will receive a complexity that's in a very huge order, N square, M square, something of this order. Will this work? Not at all. N square, M square order will not work. Make sense? Hello? All right. So Saur is saying yes. Is everyone else able to follow this part? Like why brute won't work? All right, cool. Now let us see. If brute doesn't work, I will now ask myself, what was required? The requirement was, if I'm standing at a row, any component that lies just on the top row and just on the bottom row should get added by its size in the contribution of this row. Yes or no? Meaning, let's talk about this. If I talk about this row number 4, it has a total of 5 size. Connected to this, I have 3 components. One component is this. One component is this whole 1, 2, 3 line component. And then one component is this, these 2 hashes. If I am able to somehow deduce what is the size of each component connected in the above and the below row quickly in a faster manner, not by doing a DFS, but by quickly, like maybe in a constant time, then will I not be able to get the answer or not for that row? Make sense? So this is where DSU will come into picture. Now, what is DSU? DSU is a DSU disjoint set union. This is a data structure which has like disjoint set union, which has almost like, it has not been proved exactly like otherwise, but you can say almost equal to a constant time complexity to maintain in a graph. Like if like prerequisite to this problem would actually be how to find the size of connected component by DSU. This might be a problem on lead code. You can solve this, pause this video over here, solve this problem and actually come back to this problem. So you will understand this better. So by DSU, there is a very direct constant time complexity approach by which we can report size of every connected component. Now, if that is available with DSU, what I can do is create a DSU. And then let's imagine I was on this 4th row. So this was the row 1, 2, 3. Look, I'll draw this, sorry. 1, 2, 3, 4, 5. Now there is a hash above. There is one hash that connects like this. And then there is a hash like this. So what I can do is, while I'm traversing on this row, I can check the above and the below cell. If the above cell is a hash, or if any, so if the above or below, any cell is a hash, then what I can do is, a DSU, this is actually a component, like this would be a component. This is a component, this is a component. And in a DSU, each component has a leader. So this component will be represented by a leader. This will be represented by a leader. This will be represented by a leader. So what I can do is, I can store all the leaders connected to this cell in the top and in the bottom if it is a hash. Sil which gets added to leader. Yeah, it gets added to the leader part. Yes. So when I was on this cell, I will say the top cell has a hash. So I will add the leader of this component in a structure. Let's say there's a container over here. Add this leader. Let's say this leader is L1. L1 gets stored. Now I'll move on to this cell. In the top, it has a hash? No. In the bottom, it has a hash? No. In the top has a hash, bottom? No. Top has a hash? No. Bottom, yes, has a hash. If it is a hash, what is the component? This is the component. Its leader, let's call that L2, add L2. Then this part has a hash, has a hash. So this has a hash, its leader is L3. Yes, its leader is L3. So I need to add L3. But then when I have the bottom hash, it is also having a leader. It is a part of a component, that leader is L2. But tell me, haven't I already added L2? Will you want to add L2 again in this? No, right? Because you have already covered this component. So that means when I say I would be using a structure, this structure would actually be a set, so that I only maintain unique values. Are you following this? So when I'm in a row, I will push all the possible leaders of the component connected in the top row and the bottom row for every cell. And then when I finish this traversal of a single row, I will have 3 leaders with me. Corresponding to these 3 leaders, in my DSU, I would have already stored their sizes. So I know leader 1 component sizes will be 1, leader 2's component size would have been 3, leader 3 component size would have been 2. So can I not iterate in my set now and add 1 plus 3 plus 2, that gives me 6. That means if I convert this row to fully hashes, I would get an answer of 6 plus this size of row, that's 5, 11 or not. Are you catching up with this part? Make sense? All right, cool. So I told you to do this for a row. Now you can do the same for a column or not. You can go to every column, check for its left and check for its right. Same approach. Make sense? Correct? So again, for any beginner who is watching this video, if you're not familiar with DSU, if you're not familiar with graph connected component, I strongly recommend you to pause and read about the prerequisites. Otherwise, this is going to go over your head and you will say in the comment, I did not understand that, bad explanation, whatever. That's not going to be the case. All right, who am I getting? I have a crucial algorithm in course. Exactly. You will get this part. Like every problem is not beginner problem. This is a prerequisite problem. So I cannot help it, right? But this requires DSU. Now DSU can be done with any structure. I would have solved this one if I was exactly sure. So now this becomes a observation for you, right? Now again, I don't want to implement, like make you understand what would be the internal implementation of DSU, what is maintained in DSU. That is why you are getting this leader and all this stuff. It doesn't matter. Let's say I give you a DSU and I give you the functions of the DSU and I tell you these functions will give you this. Now can you solve the problem? You can, right? So that is the whole part. Like I also like DSU as a data structure is something which is taken as a template. So I also have a template of DSU. I directly copy paste it and solve the problem wherever needed. And this is what I have done in this problem also. Any problem? So a prerequisite to this problem would be this size of connected component by DSU. This would be on lead code. Anyone who's watching this can actually solve this first, then come to this part. You will understand it. All right. All right, cool. Now some implementation tricks, how I have done this. Now, if let's say there's a 5 cross 5 matrix, this is 1 cell, 2 cell, 3 cell, 4 cell, so on. Then obviously you cannot represent them by I, like they are represented by I, j. Correct? But in a connected component, am I talking about a graph? If I'm talking about a graph, I obviously want a node. So it would make sense for me to represent them in a single value. That is why in my implementation, what I've done is I have converted them as m into I, not m into I plus j. What would be the physical meaning of this? Can you tell me? Like if m is 5, I is 0, and then j is also 0. This gives me 5. This gives me 0. Then this would give me, what would this give me? This would give me 1, 2, 3, 4, and so on. Do you get this? Like what I'm done is basically I have marked all the cells from the top left to the bottom right as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on. This would go till 24. So I basically converted 1 into n, 1 to n into m, or in my case, what I've done is 0 to n into m minus 1. This is what I've done. Now, I have done this because I want to represent every cell as a singular value, singular unique value, so that I'm able to maintain a connected component of that. All right, clear? Now, what would be my time complexity? DSU is going to do everything in a constant time. And then you are using a set. So you will have somewhat like a n into m. That's definitely there because you're iterating in the 2D array into set size. Now the set size is going to have log power because insertion in a set is log. Correct? Is that right? So you will get somehow like somewhat of this complexity, which is definitely going to work because n into m is definitely there. And then log of this set size is going to be maybe like 10 or 12 terms maximum. So 10 to 20 terms maximum. So n into m is in 10 power, I think, yeah, 10 power 6 order. And then into that is going to be also in a good order. I think it's not zooming anymore. Yeah. All right. Now, can we look at the code? All right, cool. All right. So this is the code. Now, I have the class DSU with me. Forget this class for purpose. All right. Forget this. This was a template I directly had. Let's talk about the other part. Took n, took m, took the 2D array A, and took the input. Any problem? Now I created a object DSU, small DSU, out of the class DSU, total size n into m. Now let's look at the implementation. Inside DSU, there are two things that are maintained. One is the parent, that's the DSU, this is the constructor. Then you have the find upper sort of a function that's actually simply like, this is actually find leader. You can better name this. This is find leader. This is actually a compression path function that gives you the leader of that component. And then union by size, which actually maintains the size of DSU components. So now what will happen is, I will say, I created a DSU of a total length n into m. Go to every number, go to every value, 0 to n, 0 to m. If it is a hash, then what I'm going to do is, I'm going to connect it to its previous row and previous columns number. How do I get that part? If I and j has a hash, I will connect it with if there is another hash at I minus 1 j position and I and j minus 1 position. Meaning, if I'm standing at this, let's say I'm standing at I comma j, then I'm going to connect it with this and this if there is also an hash over here. Any problem? How do I do that? DSU dot union by size. First, I'll pass this cell, that's I into m plus j, or m into I plus j, which I showed you over here. Like I deleted, sorry, that part. And I minus 1 into m plus j. And then if j greater than 0 is possible and I and j minus 1 is also an hash, again, I'm going to union this. So when I end this for loop, what will happen is in my DSU, I will have all the connected components very cleverly paced with their leaders and with their all right. So this is a good question. Shouldn't we do it for all possible direction? It is not like it's not going to be a problem if you do for like okay. Look at the loop. How is it running? You are going to 0th row. You are going row wise from top to bottom, then column wise from left to right. So any component that has to be connected will be handled in the next structure or not. Can you think about this, Short? Like, let's say you wanted to connect this to this and this also. But later you will come to this cell and you will connect this to this back and this back. Isn't it futile? Like, can I not say that don't connect it to these two right now? Just connect it to this previous these two, because next time when I come to this cell, it will get connected. Yes, got it. Kind of rippling from top. Exactly. Kind of rippling that part. Correct. All right. I mean, you can write this line. That's not a problem. Like, it won't affect your DSU. After you end this part, you will have your connected components ready. Now, start off with a long answer. This is your answer you want to maximize. Now, first I'll find in all rows. So go to each row, 0 to n row. I have a C variable, that's the counter C, and then a set. This is for storing leaders. Storing leaders. Now, what do? I say, go to every row, every column. If it is a hash, insert its leader into the set. else increment C. Why increment C? Because that would mean if it's a dot, that means it would convert to a hash and it would contribute to the connected component. So one value need to be added. That's the C. C is the count of the current hashes in the connected component. So C gets added, and then I simply say, because this is the row, so C, if I'm maintaining rows, then I plus 1 and I minus 1. These are the two things I need to check. Is I plus 1 row existent? If yes, then is it a hash? If yes, find its leader and insert. If I minus 1 is existent and it's a hash, find its leader and insert. And when I end this for loop now, for this row, ith row, I will have all the possible leaders of all the connected components that should have come into picture. And because that is done and dusted, now I can iterate in this set and just add the size of that connected component from the dsu.size array to my C. And this C is going to be the current connected component size if this row would have turned full to hashes. And then you can maximize this C with your answer. And then I will do the same for columns. Same thing for column. What is the upper bound of size of set? All right, so upper bound of size of set is going to be n or m dependent. Like upper bound is going to be 10 power 6. Because what can happen is n into m is 10 power 6. So n can be 1, n can be 10 power 6. So upper bound is going to be 10 power 6. You will set someone as its leader and you will only be able to use that component by its leader or what? Yeah, exactly. That's the case, Manmat. Yeah, exactly. So like DSU works like this. What will happen is every component will now be represented by one leader, and that leader's value will be the size of that connected component. So whenever I will call that leader, that is IT stored in set, I will get its size of that connected component. And then I can add that to C. And how do you check it is connected to that chosen row? It's connected because, like I showed you over here, right? If you're traversing on this row and you change this to a hash, like I'll change with blue. If you change this to a hash, it will now get connected to this top hash or not. It will know. So you will check this by the top row and the bottom row. If this gets converted to a hash, it will get connected to anything that's on top and on bottom. Now, on top and bottom, nothing is there, so it doesn't get connected to anything. This is a hash. This is a hash, so gets connected over here. This is a hash, so gets connected over here and here both, but you are maintaining a set, so this leader gets counted only once. All right. Cool. All right. Now, what is the time complexity? As I told you, n, like this is n into m inside this, which you are running a set. So like maximum upper bound on set is 10 power 6, right? So I can actually report my time complexity to be something like this. Time, yeah, something like this. N into m into log of n into m. Something like this. Make sense? Correct? And then what is the space? Space is obviously O of n into m. Why n into m? First of all, obviously for the size of array also. That's very obvious, like the 2D array, you're taking up the size. And also for the DSU, if you look in the class implementation, you actually have to implement the parent and the size array. That's also n into n size you passed over here, which is taking a creation time as n into m also. So that's also have to be implemented. Overall, giving you a good time complexity, n into m into log of n into m is definitely going to work. All right. Cool. Are we done on the problem? All right. So that is all from my side. I'll be attaching the problem links and everything. I hope you enjoyed the PCD. Right. Hey, Viraj, great simplification. Loved how patiently you took your doubts. I'm also from Lucknow. Yeah, exactly. All right. Thank you. Thank you so much, sir. First time attending PCD. Really nice. All right. So my username is actually this. Like I have two IDs. This is my dumb fake one. This is my username. You can look at this in the video later on. All right. Cool. So I'll be stopping my recording. Thank you everyone for today's PCD.